So we're going to go ahead and try to get this one here in the proper form so that we can find all this stuff and graph it. Well, the first thing you need to decide, are you going to get it into the y equals form or the x equals form? Well, here we have y's being squared, so you need to choose the form that has y's being squared. So in other words, it's x equaling and where your y's are being squared. So this is the form we need to get it into. So we need to complete the square with the y's. So completing the square here with conic sections is going to be a little bit different than some of the other problems. So first of all, we're going to start out by grouping the y's together. Now, remember, in completing the square, you only want to have a positive 1 in front of your y squared. So I'm going to factor out that negative 1 from just the parentheses. And that means that negative 1 I didn't do squat to, so it's still hanging out back. Now, I have that negative 1 in front. Now I need to complete the square at the y, so I need to take half of that 4 and square it. So I'm going to put half of 4, which is 2, and square it and put it right here. Now keep in mind there's a negative in front. Now, whatever I add here, I need to subtract over here. Because if I add something and then subtract something when I'm on the same side of the equal sign, it's a net change of 0. So if I added a 2 squared here, I need to subtract my 2 squared. But keep in mind, this 2 squared I put right here is in parentheses. It's affected by that negative 1 in front. So I added a negative 1 times a 2 squared. So I need to subtract a negative 1 times a 2 squared. So factor the parentheses, negative y plus 2 all squared. Then I take a look over here. 2 squared is 4, minus a negative is adding 4 under 3, so that gives me, or negative 1 plus 4 is 3, so I get this. So now, I have a negative in front of my y, so I have x equals. I know I either open to the right or to the left. It's a negative in front of the y's, so that means I need to open in the negative direction of the x's, so I'm opening to the left. So now I need to find my vertex. Remember, when you're opening sideways, the h and the k switch. The h is what's on the outside. So my x coordinate of my vertex is 3. Then my k is what's on the inside, and you always take the opposite of that, and so that's 2. So my vertex is 3, 2. Now, you can always go ahead and make yourself a t-chart to be able to graph this. Now, normally we choose values for x, plug it in to figure out what y is. And that works great when it's y equaling something with x's in it. But we have x equaling something with y's in it. So I'm going to go ahead and start with my y values. Well, how do I know what to start out with? Well, the y coordinate of my vertex is here. So I'm going to choose 3 numbers on each side of that. And then I'm going to go ahead and fill out my t-chart. That's one way to do it. A second way to do it is to go ahead, and use the pattern of 1, 3, 5, 7, and so on. So I'm at my vertex of 3 to the right, 2 up. If I go up 1, I need to go left 1. Up 1, I need to go left 3 because I'm using the pattern of 1, 3, 5, 7. Then if I go up 1, I'd have to go left 5. If I wanted another point, I'd have to go up 1 and left another 7. And then that works going the other way. So down 1, left 1, down 1, left 3, down 1, left 5. And then whether you plot your points from a t-chart or use that 1, 3, 5 pattern, doesn't make a difference. You get the blue parabola. Now, remember, your axis of symmetry is a line that cuts it in half. In this case, it's a horizontal line. So it's y equals, and it's always at a height of 2, so it's y equals 2. Length of your latus rectum is 1 over a. Well, a is that negative 1. Sorry. So we go ahead and take 1 and divide it by that negative 1, and 1 over negative 1 is 1. Absolute value is positive 1. So that's the length of our latus rectum. So if we went from our focus here and went straight up and down, that would be a length of 1 unit. So how do we get that focus? Well, remember, we need to go and look at that 1 over 4a. 1 over 4a tells you the distance from your vertex to your focus or vertex to your directrix. 1 over 4a, and a is that negative 1. So we go and plug in that. We get 1 over 4 times negative 1, which is 1 over negative 4. But remember, it's absolute value. So that distance is 1/4. Now, we were opening to the left, so that means we need to go 1/4 to the left of our vertex. If we were opening to the right, we'd go 1/4 of a unit to the right. So our vertex, once again, was 3, comma 2. If we go 1/4 of a unit to the left, that only affects the x. So we go 3 minus a fourth, and we get 11/4. We didn't change the up and down, so our y value is still the same. Now, our directrix is also that 1/4 away, but that's in the opposite direction. We want 1/4 to the left to get the focus, so we got to go 1/4 to the right. If we go 1/4 to the right, 1/4 to the right would be then a vertical line right here. Well, if you're at 1/4 to the right, that's only going 1/4 to the right of what the x was. You were at 3, you go 1/4 of a unit over, and you get x equals, it's x equals because it's a vertical line, 13 over 4. Remember, your focus is always a point, directrix is always a line. Sometimes vertical, sometimes horizontal, depending upon your problem.